of time. I was like doing a
Okay. Okay. Yes, Kaima. I thought you were, I think you were gone for a run or something. Okay.
Yeah, I just
You're
came
back.
home.
Okay. That's fine. I have recorded the previous, class for you. Uh, I'll recap a little bit of what we've done. We've, covered moments. We've covered torques. Torques is basically, the product of force into distance, right? So you have to make sure that the force and the distance are perpendicular. If the force is in this direction, then distance has to be 90-degree to it. Okay. And now we're just writing down the principle of moment. Principle of moment says that the sum of the clockwise moments are equal to the sum of the anti-clockwise moments in equilibrium, right? Because in equilibrium, you have to have two things. In equilibrium means that the resultant force is zero, and it also means that the resultant moment is equals to zero. And resultant moment is what? It is the difference between the clockwise moment and the anti-clockwise moment, right? For example, if you have a door and someone is applying a force in this direction, that is going to make your door turn in a clockwise direction, right? But if you have a door and someone is applying a force in the other direction, then that means the door is going to turn like this. It's going to turn anti-clockwise. So the net moment is going to determine, it's going to depend upon whether there is a net force in the clockwise direction or a net force, a net moment in the anti-clockwise direction. Okay. You will have to watch the lecture to get a better understanding. Now we're going to move on. Okay. Let's record this one as well. Oh, we've got it. Okay. Now we did the IGCSE version. We've done IGCSE up till now. We did the IGCSE version of principle of moments, right? Sum of clockwise moment equal to sum of anti-clockwise moments, right? So you would have anti-clockwise moment equal to clockwise moments. That means, if you add up the force into distance for clockwise, they should equal to the force into distance for anti-clockwise if in equilibrium. Okay. Now, now we're going to do the A levels version of it. Okay. Now, for example, again, this is theta. Okay. Now think about it. In this case, we have three forces. Okay. But all of these forces are at an angle. Okay. That means you will probably have to resolve them into their components to get the perpendicular component of the force that's acting. That is, perpendicular to the pivot. Okay. So for example, if this is, let's say, this is D1, then this is D2, and then this is, for example, this is D3. This is D3. Okay. Now, how do I write the principle of moments for this example, right? By the way, this is the pivot. This block is the pivot. So that means the bar is either going to turn like this or the bar is going to turn like this, right? It could either turn clockwise or it could either turn anti-clockwise. Now, how do I write it in, assuming we have angles, right? Because you know that the force must be perpendicular to the distance that you're taking. So that means you will have to make the force perpendicular to the distance because this force has a perpendicular component as well as a horizontal component. So that means you can find out what the perpendicular components of those forces are. So the sum of clockwise moment should equal to the sum of anti-clockwise moment. Now, what are the clockwise moments? I think that this force is probably going to make the bar turn like this. It's going to turn it clockwise. Okay. Now, think about it. If this force has F1 in this direction, then that must mean this has two components. It has a component F1 like this. And what would this be? This would be F1 cos theta 1, right? And it's also going to have a horizontal component, which is going to be this. It's going to be F1 sine theta 1. But is this going to contribute to the moment? No, because do you see that the distance and the force are parallel in this case? So that means the sine theta component is not going to come into the equation as well. So that means what are the clockwise moment? This is going to make the ruler turn or the beam turn clockwise. So that would mean F1 cos theta 1 multiplied by d3 is one of the clockwise moments. Okay. Plus, is there any other clockwise moment? Let's check. I think if I look at F3 force, it's going to make the bar turn like this, right? Because you're kind of like pulling from over here, which means it's going to make the ruler turn like this. It's going to make it turn like this. Now, that means it's going to have two components as well. This force has two components. So that means it has this component. And what is this component going to be? It's going to be F3 cos theta 3, right? Because the angle given is this one, not this one. That means it's going to have F3 cos 3 theta as, why am I taking this force and not the other one? Because the other force is going to be this. It's going to be F3 sine theta 3. Now, do you notice that this force is actually parallel to the distance from the pivot? So that means that force is not going to contribute to the moment. Only this one is, because this force is perpendicular to the distance. Okay. So that means this is another clockwise moment. This F3 is going to make the object turn in a clockwise direction. So that means this is F3 cos theta 3 into what distance? Into D1. So these are the sum of my clockwise moments. Okay. Now, what about the sum of my anti-clockwise moments? Let's check. I think again, oh, wait 1 second. So the clockwise and okay, this should be in the other direction. 1 second. Okay, F2, and this has theta 2. Okay. So now this F2 is also going to have two components. It's going to have a component of F2 in this direction, and this is going to be what? Because it's with the angle, that means it's going to be F2 cos theta 2. Whereas it's also going to have a horizontal component in this direction. So this is going to be F2 sine theta 2. But that's not going to contribute to the moment at all, because it is parallel to the direction or the distance with the pivot. Okay, so that means the only anti-clockwise moment we have is F2, because this is going to make the ruler turn in an anti-clockwise moment. It's going to turn it anti-clockwise, right? Because if you have the bar like this, then that means if you apply a force on this side, it's going to make the rod turn like this in this direction. So that means it's going to be F2 cos theta 2 into what distance? It's going to be D2. And this is how you write the principal moments in a slightly advanced version, where the forces are not perpendicular to begin with. You have to come up with the vector component to make sure that the forces you're taking are perpendicular. Okay. Yes. Any questions?
No.
No. Okay. Okay. Now let's move on straight to questions. Now try to solve this question by yourself. Right? Question says a uniform beam of weight 40 newtons is 5 meters long, is supported by a pivot situated 2 meters from the pivot. Right? So this is 2 meters. And when a load of weight W is hung from that end, the beam is in equilibrium. The question is, what is the weight? What is the weight of the beam? No, wait, sorry, weight W. This is weight W, right? You've got to find out what is the weight W. I'll try to explain the question a bit. Think about it. Now, you have a very long beam, okay? And if you pivot it over here, okay, then for example, assume that you don't have this weight, okay, then that means obviously that if you don't pivot it at the center, it's probably going to turn like this, right? It's going to fall down from the other end, okay. But in order to prevent that, you add a very heavy weight so that this side does not fall down, right? Because if the weight was not there, then obviously The weight of the beam is going to make your bar turn like this. It's going to turn like this. Just like, for example, if you try to balance your pencil from one end, it's obviously going to fall through the other end. But in order to balance that, you can apply another weight W to make sure that it does not fall in that direction. Okay. Now the question is, what is the weight W? Okay. So that's the question. I'll give you 2 minutes for it. It's a pretty simple example. Okay. Yes, Abiha, did you get it?
Yeah, I'm still trying to solve it right
Okay.
now.
Okay. Yes, Ares. Any ideas?
I'm still trying.
It's pretty simple. This is not a difficult question at all. Mhm. Always write down in a question of moments. If you read the word equilibrium, that means the sum of clockwise moment is equal to the sum of anti-clockwise moment. Okay, that means if you add up all the clockwise moments and you add up all the anti-clockwise moments, they should be equal, assuming that you have. Okay, Hania has said 60 newtons. Okay, it might be right. Let's check it out. First of all, a very important word over here is a uniform beam of weight. Whenever you have a uniform object, that means that all of the weight of that object is acting at its center. Okay. So if the bar is 5 meters completely, that means all of the weight of the bar is going to act at its center, right? And how much is the weight? It's 40 newtons. Do we know what this distance is? Yes, we do. We know that this is 2.5. And I know that this is also 2.5 because, it's acting exactly at the center. Okay. Now, can we figure out what the moments are, right? This is the weight of the bar because the weight of the bar is also going to act as a force, right? It's also going to make it turn, right? Because if, for example, if you did not have this block, then because of this pivot, the weight of the bar is going to generate a moment, and that's why the bar is going to turn like this. Okay. Now, what else? Yes. So sum of anti-clockwise moment is equal to sum of clockwise moment. Now, is the weight of the bar going to generate a clockwise moment or an anti-clockwise moment? It's going to make the bar turn clockwise, right? So that's going to be 40 multiplied by what distance? Now, what distance is it going to be? If you already know that this is 2 meters, then isn't this going to be 0.5 meters, right? Because you know that the entire thing is 2.5. So this is going to be 0.5 plus what is the anti-clockwise moment? Now, because the weight was going to make the bar turn clockwise, you added a supporting weight on the other side to make sure that the bar does not fall down on the other side. Now, this is going to generate an anti-clockwise moment. Okay. And how do you measure what that is? That is going to be W multiplied by what is the distance till the pivot? It is 2 meters, right? So that means W into 2 is equal to 20. So W is actually going to be 40 meters. Oh, sorry, it's going to be 10 newtons. 10 newtons, 1 second. W into 2 and then 40 into 0.5. Yep, that's right. So W is going to be 20 over 2, 10 newtons, right? So that's how you measure it. Okay, so you've got to measure the distances. The word uniform and the word equilibrium are extremely important. You've got to figure out. So this was the weight of the bar, and what was the distance till the pivot? It was this one, right? And what was the distance from W till the pivot? It was 2 meters. Okay, so you just had to do clockwise moment equal to anti-clockwise moment. Anti-clockwise moment was this, and clockwise moment was just 40 newtons. Okay, any questions? Yes, Abhiya, did it make sense now? Aras and
Yeah, that's
Hania.
what I got.
Okay. Okay, Hania, it's not 60, sadly. Okay. Now, next question. Now try this one out. This is also a good one. Question says, this is the rod which is in equilibrium, okay, with length 10 meters. Okay, so that means the length of this entire rod is 10 meters. You have to find out the weight of this uniform box. That's it. That's the entire question. They are in equilibrium, okay, and you have to find out the weight of this uniform box. That's the question. Okay. You also have a force over here. You also have a force over here. And this is supposed to be a, oh, wait 1 second. Let's make this. This is going to be 250 Newton. And this is supposed to have a theta of 30 degrees. Okay. Here's the question. Okay. Did you get the question? Okay. You missed start. This is a 3-mark question. 3-mark question. So that means it's going to have some amount of working. We're done with this chapter, by the way. We're just left with questions. Yes, Ariz, any luck so far?
No, I'm still doing the question.
Okay. Yes, Hani, any progress? Kaima, are you able to understand anything?
I'm like trying to like do it.
Okay.
Yeah.
Okay. If you want, you can leave. I will send you the recording for both classes because it's not going to make a lot of sense if you haven't attended the first one. Okay, that's up to you if you want to stay or not.
Yeah, I think I'll stay for some. Yeah.
Okay. But make sure you watch the recording for the previous hour because I covered all of the basic concepts in that. Right now we're just doing questions. The content for this chapter is really, really small. Right now we're just doing questions. That's it. We're done with the chapter, and we will spend another class or probably two to solve difficult past paper questions, and then we're going to move on to the next chapter. With the next chapter is going to be density and pressure. We're going to talk about forces of upthrust, pressure in liquids and solids, and the origin of upthrust. A lot of questions are combined with that. In fact, what we'll do is we'll try to do a few questions for this and then immediately jump to the next chapter because a lot of the questions for density and pressure are connected with moments. So that's why, we'll do the past paper questions probably at the end. We'll see. Okay. I'm
So,
gonna, yes.
so what's the distance between the 300 newtons force and like the pivot?
Hmm. That's a part of the question. Think about it. If the entire rod is 10 meters
Oh, okay, yeah. So, and you're
and
already given the other
and
lengths.
isn't this 5 meters? Doesn't that leave this also 5 meters?
So it would be two.
2, yep. Because they won't always tell you the distance straight up. You'd have to figure it out yourself.
Okay.
Okay. Okay, I'm going to start solving it. So, again, if you read the word equilibrium, what should immediately come to your mind is that this answer, sum of clockwise moment is equal to sum of anti-clockwise. That's the first thing that you should write. Even just writing this might get you a mark. Okay. Now, what are the anti-clockwise moments? Let's first write those down. Let's check. I think that uh, this force is going to make the bar turn like this. So this is a clockwise moment. But what about this force? Now, this force has two components. It has this component. Now, what is that going to be? That is 250 cos 30, right? And that force is going to make the bar turn like this in an anti-clockwise moment. Okay, now let's write down what the anti-clockwise moment is. That is 250 cos 30 multiplied by the distance 5 meters from the pivot. Okay, now is there any other clockwise moment, anti-clockwise moment? Now this is going to make it turn clockwise. Now what about the box? Now read very carefully. It says uniform box. That means all of the weight acts at its center, W. Okay. Now, if all of the weight acts at its center, doesn't that mean that if the entire length of the box is 0.4, that means this side should be 0.2 and this side should also be 0.2. This side should also be 0.2 if it's uniform. So now think about it. How do you write the expression of moment for this box? Now, I know that it's going to, by the way, this is going to make the bar turn clockwise. Now, what is the expression for that? That's going to be W multiplied by what distance? Now, check this out very carefully. If this entire thing is 3 meter, if this entire thing is 3 meters, right? Let's use this. If this thing is 3 meters, that means if you subtract 0.2, you're going to be left with this junction, right? So that means if this is 0.3, and this section is 0.2. That means this section is just going to be 0.3, sorry, 3 minus 0.2, right? So that means this section is just 2.8. This section is just 2.8. So that means the distance from the center of gravity of this W is actually 2.8, because the 3 meter is actually till the end. But all of the weight is supposed to be acting at this point, and this point would actually be 2.8 meters from the center. Did that make sense? Two point eight. Plus, is there any other clockwise movement? Yes, there is. It's this force. So 300 multiplied by 2 meters over here into 2. And that's how you find out what W is. If you write this down, so, just choose some algebra to figure it out. So W is supposed to be 250 cos 30 into 5, and then divided by 2.8 into, no, wait, sorry. That is minus 300 into 2, right? Divided by 2.8. And whatever that is, that's going to be the weight of the block, or whatever that is. Okay. And that's how you calculate whatever that value is. Doesn't matter. Sure, you can calculate it. Okay. Yes, any questions? Should I move on to the next one?
Are the decimals, how many decimal places we have to write it? Like 3 or 2?
I think 2 decimal places are more than enough. So like if you're getting, what are you getting the answer as?
I'm getting 172.333. So
3333
odd.
and so on. So even if you round it off to 3 significant figures, that's fine. So that means if you write the answer as 172, that would be right.
Okay, all right.
Even this is correct. And if you want to be even more accurate, then you can write 172.3. That's right as well. Okay, but you don't need to write like 6 significant figures.
Okay,
Okay.
so only 172.3 max.
Okay. 172.3. 172 is also correct.
Okay.
Okay. Now, next question. This is a wheel, okay? And this wheel is in equilibrium. The question is find this force F. How do you do that? It's pretty simple. We know, so if this is a wheel, okay, that means that this entire thing is going to turn around like a wheel. Okay, so that means if you apply, if this entire wheel is connected and you apply a force over here, then this entire wheel is going to spin in this direction. But if you apply a force in the other direction, like this, for example, if you apply a force like this, then this entire wheel is going to turn around in the other direction, just like all wheels. Now, but the forces are, at different points at different, spokes of the wheel. The question is, find the force F. Okay, this is a pretty simple one. This should not take more than 2 minutes. You just have to plug in the values. Again, sum of clockwise moment is equals to sum of anti-clockwise moment. That's all. You just have to write down which are clockwise and which are anti-clockwise. Yes, what did the value come out to? 80 Newton. Okay, let's check it out. So, anti-clockwise moment is supposed to be, let's check. You just have to identify which is going to make it turn clockwise or anti-clockwise. So this is going to turn the wheel clockwise. This is also going to turn the wheel clockwise. But this force is in the other direction. It's going to make your wheel turn anti-clockwise. And this is probably going to turn the wheel clockwise as well. Okay. Now let's check it out. So I think the clockwise moments are F into 3, right? Because this is the perpendicular distance till the pivot. Plus, it also has 30 into 2 plus 50 into 2, right? Okay. But there's an anti-clockwise moment as well, which is 200 in the other direction. So 200 into 2. Okay, let's check it out. So this would be, so 200 into 2 minus 30 into 2 minus 50 into 2 divided by 3 is going to equal to F. And that's how you find out what the force F is. Okay, pretty simple example. Shouldn't be a problem at all. Okay, now moving on. Any questions? No? So I don't know what that value is, but whatever that is, it must be right. Okay, now moving on. This question. Also pretty simple example. Now the question is, so this is a uniform rod, okay, and the length of that uniform rod is 100 centimeters. The question is, what is the force exerted by the spring if in equilibrium? Again, also really simple example. Try it. It should not take more than 2 minutes. This is a very simple IGCSE example. The pivot is on the left side, by the way, where the block is, the triangle. Yes, Abiha. Can you help me calculate what the value is?
Yeah.
Yes, what does it turn out to?
For the clockwise moment, we can like um times the weight of the rod
Okay.
times
S- s-
0.5.
Yep, that's right. So this is going to be 500 newtons multiplied by 0.5, right? Because the weight of the rod is acting in this direction and it has a distance of 0.5 meters from the pivot. Okay, great. What about the force from the spring?
We need to convert 100 centimeters to meters first, which would
Hmm.
be 1 meter. And you just times that by
Hmm. Where
the
is the
force by
force?
this. We need to find that. So
Where is
we
the force
just
on the spring, by the way? Is it like this or in the other direction?
it's in
Like
uh
this?
yeah.
Yep, that's right. It's right. It's going to be like this because imagine that if the spring was not over here, then this entire beam would fall down like this, right? but it was the spring that was holding it up. So that means the spring must have been providing an upwards force. So that must mean it's going to be F into 1, right? So that means 500 to 0.5 is the answer. So 250 newtons is the answer. That's it. 250 newtons is the answer, which is equals to F. Okay, sounds great. Okay, one more question. Now, this is a good one. Now, question says, figure 1.2 shows a kitchen cupboard resting on a support attached to a wall by a screw. Okay. The weight of the cupboard and its contents is 75 newtons. Okay. G is the position of the center of mass of the cupboard. Okay, so this is the position of the center of mass. The clockwise and anti-clockwise moments about P are equal. Calculate the force exerted by the screw. This is a 3-mark question. Slightly tough one. Now, first of all, I'll explain the question a bit. Now, imagine that all of this, this entire, this is basically, this is a kitchen cabinet. And this kitchen cabinet is supported over here. It's supported at this point. Okay, so that means, for example, if the screw was not over here, then this entire kitchen cabinet is going to fall down in this direction, right? Because it's all being supported on this little point. Okay, so that means if for example, the screw was not over there, right? The kitchen cupboard was not screwed to the wall, then what would happen is, because of the weight of the wall, this kitchen cabinet is going to fall down like this. It's going to fall down in this direction. Why? Because of the weight, right? But in order to make sure that it did not fall down in that direction, you had to screw it to the wall, right? And that's where the screw comes in. Okay. So that's the question. And you have to calculate the force exerted by the screw. I'll give you 5 minutes
So,
to try to figure this
so
out.
then
Yes.
over here, like the pivot would be P, right? The support area.
Uh, yes, that's the pivot. This is the pivot.
Okay.
So all of the forces are going to act about this point.
And what do we need to find? The force exerted by the screw. Okay.
Yep,
I
that's
think
right.
I think I understood it.
Okay.
So I'm not sure, but would F be equal to 24 newtons?
Okay. Might be right. Yes. Abiha, what answer are you getting?
I also got 24.
24. Okay. Then that must be right. Let's check it out. 1 second. Okay. Let's check it out. So, first of all, you know that if this is the pivot, okay, that means if this is the pivot, the weight is probably going to turn this entire bracket in this direction, right? So the weight is going to turn the bracket like this. It's going to make the entire bracket fall down like this, right? So that means the weight is going to make it turn clockwise. Okay. So always write down sum of clockwise moment equal to sum of anti-clockwise moment. Okay. The clockwise moment is just now. What is the force of the weight, it is 75 newtons. And what is the perpendicular distance for pivot? That's 75 into 0.24. And what is the anti-clockwise moment? Now, the screw is making sure that the cupboard does not fall down in that direction, right? That's the screw is holding it in this direction. So that means this is going to provide an anti-clockwise moment. Okay. But what is the distance from the pivot? It is actually this one, 0.75, which is the perpendicular distance from the force. So 0.75 into F. So that means, 75 into 0.24 divided by 0.75. What does that turn out to? Is that 24? Or no? Is it 24? Should be. Yep, that's right, 24. Okay, 24 newtons is the force. Okay, sounds good. Okay. Hmm. I think that's all for today. We've done a few questions. We'll do a few more, slightly difficult questions. And we won't spend a lot of times right now on questions. We're first going to complete forces, density, and pressure. And then we're going to, do the topical questions for this chapter together, because most of the questions are connected, with upthrust and moments, and they're also connected with density and pressure somehow. So that's why most of the questions that you get are connected. Okay, because we've only covered the same things as IGCSE with a slight addition with the resolution of forces. That's it. That's the only additional thing that we've done up till now. But the difficulty of the questions might be slightly different. Okay, sounds good. Okay, I think that'll be all, and I will see you on Wednesday then. Okay, I will.